Well, looks like we have ourselves a short cord reel that we're going to look at today. What's the complaint on here? Struggling to roll in. That's all I got. So I don't have my full complaint cause and correction on this one. Seems to be that the customer or technician thought that it wasn't quite reeling in quickly enough for them. So they brought it in and replaced it. Now, some things that we need to know about this, just kind of setting an expectation. This cable, our 50 amp short cord here, this can get kind of gummed up, it can get kind of dirty, various things on it that can hamper its ability to come in. That'll make it a little bit more stiff as it's coming in. The real thing we want to be paying attention to when we're trying to diagnose any sort of issue going on with our short cord reel, specifically the retracting part. All it is an electric motor on the inside of this, right inside here. And so basically we just want to make sure that we have good proper voltage, 12 volt, hooked up to our leads here, and we should be able to see it retract like that. Now by spec, the motor in here is a 5 to 6 amp nominal, so it's normally under normal load is going to pull 5 to 6 amps. At its peak it'll handle up to 10 amps. So the way that we would test this is first we want to make sure that we've got good power coming to it, and then when we're reeling in our cord we want to see somewhere in that 5 to 6 amp range. If say there's rust in here causing the reel to bind as it's coming, basically anything that's going to make the reel more difficult to retract, we're going to see that amperage go up. So we're going to see it resting in the 8s or 9s. We're going to see it hitting that 10 amp limit more frequently. If on the other hand we're starting to see the motor go bad to where it's stripping internal components, we're going to see the amperage go down. So we're going to see gradually it's going to go lower and lower as effectively the magnet on the inside of that motor is just spinning within the case and not actually binding to what it's supposed to, turning what it's supposed to. So we're going to see the amperage go down in that instance. In the ballpark, we're going to be looking at, like I said, 5 to 6 amps. That's going to depend on which specific short cord reel it is. All of these products have their own manuals, and always check your manual for the perfect specifications. But this particular one, I know from reaching out to the manufacturer that we should be seeing 5 to 6 amps. So let's hook it up. All right, I got my positive hooked up to my positive. I've got my negative hooked up to my negative. I'm going to tilt this up so that the camera can see it, and I'm going to turn this on. We're going to watch and see. Look at that. I'm at 5.2 amps. And yeah, I'm drawing in a little bit slow, but it's still coming in. This isn't any sort of a race. It's going to come in, and as long as it's coming in and as long as we're pulling the right kind of amperage, we're good to go. Now, another potential that we could have had, if I mentioned that we need to make sure we've got good voltage coming in. So if I bring this back out, and then I'm going to drop the voltage on my power supply here. That first test was at 13.7 volts. I'm going to drop it to 11.7 volts. So that way we are below the range of what you would really want to see an AGM battery running. Let's do it now. See how much slower it's retracting now and how much more it's struggling. We're still pulling that 5 amps. But look at that, we even stopped prematurely. Low voltage can absolutely be one of the reasons that it operates incorrectly. So we want to make sure we've got good proper voltage. We want to make sure we're reading the right amperage when we're doing it. If we're seeing those two things, it's operating within spec. The customer just needs to set their expectations a little bit differently.